Hello! This module is entitled Composable Company. The learning outcome of this session is to understand how a composable company operates and how to create a flexible and scalable infrastructure. Two are the basic concepts that we are going to discuss today. First, we are going to analyze process design activity in order to figure out how to build a modular business process. And second, we have the concept of business composability with its benefits, principles, and foundations. So, what process design is all about? Let's deep dive into today's literature and find out how the design of a process matters greatly to efficiently run a business. The core of this section has to do with process design. We are going to analyze the factors that affect the process design activities, the typology of product and service processes, and focus on each stage of a product or service design. Although process design and product service design are quite interrelated, many people treat them as separate activities. Of course, it is wrong to commit to the detailed design of any product or service without taking into consideration how it is to be produced. To put it simply, when we are talking about product design, we are talking about the product's shape, its components, and raw materials that are used for its production, etc. When we are talking about process design, we are talking about how a product or service is produced, the methodology, and its sequence of production activities. Several academics such as Slack, Johnston, and Chambers define a process as an arrangement of resources and activities that transform inputs into outputs that satisfy internal or external customer needs. They are the building blocks of all operations, and as such, they play a vital role in how well operations operate. Other sources define process designs as method of creating achievable, repeatable procedures that enhance a company to succeed in a way that aligns with its values and goals. The main objective of the process design is to make sure that the performance of the process is appropriate for whatever it is trying to achieve. To give a simple example, if another product or service competes on its ability to quickly respond to customer requests, then the process design will focus on giving fast throughput times. This is how actually product service design and process design are bonded together in order to give, as a whole operation, the desired results. Due to the fact that processes are managed at every operational level, process design also needs to consider a set of objectives in a more detailed level. It's true that this micro-level operation management has a significant impact on the efficiency of the process. When a product's component enters a production sequence, it will progress through a series of activities in order to get processed to its next stage of the production. Between these activities, it may dwell for some time in inventories before it is moved to the next activity. This means that the time a unit spends in the process, which is called throughput time, will be longer than the sum of all the transforming activities that it passes through. Additionally, the resources that perform the process activities may not be used all the time because not all items will necessarily require the same activities. So, it is easy to understand that there cannot be a full utilization of the items moving through the process or the resources performing the activities. In order to control and measure the process flow performance, there are several micro-performance flow objectives such as work in progress, throughput time, and cycle time that can reveal the efficiency of the whole process. There are several benefits that a company can experience if it puts effort into efficiently designing its business processes. First, a company can improve its production by analyzing and improving current processes or implementing new ones. In this way, the company can reduce the costs by making processes more efficient by standardizing processes and making production much quicker. Another benefit is consistency, which can be achieved when designing strong processes. It is valid that companies with consistent process procedures have outstanding financial performance. An important benefit is that process design not only helps businesses connect strongly with their customers, but also enhances employee engagement. A well-designed business process can reveal some dull or repetitive tasks that exhaust the employee's mental health. In such a way, the operations manager can minimize these tasks and use the personnel's skills in a much more efficient way. Lastly, when designing processes, you can evaluate your business goals. As processes improve, you may set more ambitious goals, always taking into consideration the potential of your resources and the process capabilities. It is worth mentioning that while standardizing processes can give some significant advantages, not every process can be standardized. Standardization remains a significant issue in large corporations because very often different ways of carrying out similar or identical tasks emerge over time in various parts of the organization. In one hand, that provides the advantage of autonomy and freedom for individuals and teams to work independently and exercise their discretion. On the other hand, this independence could cause confusion, misunderstandings, and eventually inefficiency, since there could be several ways of doing things having the same outcome. For most organizations, there is always a practical dilemma: how to draw the line between processes that should be standardized in order to be more efficient and those that are allowed to be different. So far, we have analyzed the importance of process design for creating products and services as originally planned. In order to know how to design and where to pay much more attention in the production process, you need to know first what kind of product or service you are about to deliver. Operation processes have different characteristics depending on the output. According to the literature, there are 4 important factors that classify these processes: the volume and the variety of their output, the variation in demand of their output, and the degree of visibility that the customers have of the production of their output. When it comes to analyzing the process design topology, we use 2 of these factors in order to differentiate the operations based on their special characteristics. We use a volume variety continuum to illustrate these different process types. Different terms are used to identify process types depending on whether they are predominantly manufacturing or service processes, and there is some variation in the terms used. In the specific figure, on the left side, we illustrate the manufacturing process, whereas on the right side, we have the service processes. For both figures, we have in the horizontal axis the range of variety from low to high, while on the vertical axis, we have the range of volume. Starting from the manufacturing process types, on the top left, we have the project processes. These processes are involved in discrete and highly customized products, which probably are very complex, large-scale, and with high work content. Project processes have low volume and high variety. The production time schedule needs to be defined and clear from start to finish, providing detailed information about the time, the cost, and the quality objectives. A characteristic example of these types of processes is the production of a cruise ship or a big construction site. Next, there are the jobbing processes. These processes also have low volume and high variety, but the difference with the project processes is that in jobbing processes, each product must share the operations resources with many others. Customization is quite high in this category, as there is a need for skilled labor in order to complete the whole product. Furniture restorers and made-to-measure tailors are a representative example. In the middle of the figure, we can find the batch processes. Here, the ratio between volume and variety is quite balanced. These processes do not have the same variety as jobbing processes. The outputs are usually standard products with repeating demand. Through there could be some special deliverables. A unique feature of this typology is the setup at each stage of the production. An example of batch process is the backstage of a restaurant, and specifically how the kitchen processes are organized. There, the food is prepared in batches, which all must go through the same sequence of preparation, cooking, and storage, but each batch is of a different dish. Also, there could be a special order for a customer that needs an extra ingredient in his main dish or less seasoning. Getting closer to the figure's down right corner, we have the mass processes. In this typology, we have items that are produced in high volume and relatively narrow variety. The activities of mass processes tend to be repetitive and largely predictable. A classic example would be the mass production of cars from an automobile production plant where each car is almost but not quite the same and made in large quantities. Last, we have the continuous processes which have extremely high volumes and low variety. The output is usually a single product, and the production procedure highly capital intensive and automated. A unique characteristic is that it is difficult and expensive to start and stop the production process. Examples of continuous processes include electricity utilities and water processing. In the same pattern, looking at the right side of the figure, we have the service process types. In a similar position with project processes, there are professional services. These are high contact processes where the customer spends a considerable time in the time service process. The customization level is high, with service processes being highly adaptable in order to meet individual customer needs. This type of service is much more people-based rather than equipment-based, and contact staff are given high levels of discretion in servicing customers. An example of professional services would be doctors' surgeries, lawyers' practices, or the services of a financial consultant. Next, there are the so-called service shops. Here, the volume is higher and the variety is lower than the professional services. In this case, there are medium or mixed levels of customer contact customization and staff discretion. A health club is an excellent example of a service shop. The club's staff can give advice on several exercise programs and other treatments. Although every client has a unique fitness program, there are certain activities such as safety issues that follow defined processes. Last, there are mass services where the volume level is high and the level of variety is low. Here, we have many customer transactions involving limited contact time, little customization, and low staff discretion. Examples of mass services are supermarkets, airports, and telecommunication services. It is interesting to mention that as the level of variety rises, the process tasks are more complex and diverse, and the process flow is intermittent. On the contrary, when the level of variety decreases, the process tasks tend to be more repeated and divided, while the process flow is continuous. An important task in process design is to figure out not only what is designed in a production or a service, but how it is carried out. It is vital to understand that the design activity is itself a process, which is one of the most important operation processes. An initial perspective concerning the designing of products or services is that each product or service has three major aspects. First, it is the concept, which is the understanding of the nature, use and value of the service or product. Second is the package of component, products or services that provide those benefits defined in the concept. The third aspect is the process, which defines the way in which the component, products or services will be created and delivered. It is unlikely that a designer will imprint his original idea from the beginning in full formation concerning a new product or service. The design activity must pass through several stages in order to get to a final design of a product or service. In this sequence, first comes the concept of generation. At this stage, the overall concept of a service or product is developed. It is where the designer is inspired by ideas from several sources, both from within the organization and from outside. Many of these ideas are coming formally from customers through marketing activities. Another way that could trigger the designer's imagination is listening to customers on a day-to-day basis. Of course, the ideas from the R&D department or from staff, especially those who meet customers every day, are likely to have much more potential to enter the next stages of design activity. An interesting source could be some ideas that come from competitors' activity. It is true that reverse engineering is a common tool that could reveal several vital pieces of information about how competition works, whether there's a new advanced technology in the market, or how the industry is evolving. It is difficult, almost impossible, for every concept to end up as a final product or service. Organizations need to be selective as to which concepts will move on to the next design stage. This is where the concept screening stage is introduced. At this stage, the evaluation of every concept takes place by assessing each concept against several design criteria. There are three key design criteria that concepts must meet. The first one is feasibility, which answers the question of how difficult it is to get the concept fulfilled. What investment, managerial and financial, will be needed? Does the organization have the organizational capacity, the skills, or the financial resources to cope with this concept? The second key criterion is acceptability. The main question here is how worthwhile the specific concept is. What financial return will this concept give? Will our customers want to buy it? The last key criterion is vulnerability, which answers the question of what could go wrong. Does the organization understand the full consequences of adopting the specific concept? What risks do we run if things go wrong? After having generated an acceptable, feasible, and viable product or service concept, we enter the next stage of the design activity sequence, which is to create a preliminary design. At this stage, we have a first attempt at both specifying the component products and services in the package and defining the processes to create the package. At this figure, we illustrate the component structure for a remote mouse spread up in 4 levels, including the level of finalization. It is important to mention that at this stage, we may have significant opportunities to reduce costs through design simplification. There are several approaches that organizations adopt in order to reduce design complexity, such as standardization, commonality, and modularization. We will discuss these approaches in the module's next section. The next stage, we have evaluation and improvement stage, where the organization searches for any potential and feasible improvements can fit into the preliminary design. What is important about this stage is that the product or service is evaluated and tested just before it enters the market. There are plenty of tools for the evaluation process, such as quality function deployment and Taguchi methods. After the completion of this stage, we enter the final stage, where we have the prototyping and the final design. At this stage, it is necessary for the organization to run a prototype so it can be tested. Since it is too risky to go at once to full production, it is more appropriate for the organization to create a prototype or to make some trials in the case of a service. A common procedure is alpha and beta testing, where the first one is an internal process where the test is done by developers and manufacturers, while the second one is when the product is released for testing by selected customers. It is important to highlight the importance of the ability to influence the final design of the product or service. As we are in the early stages of process design, once a decision is made about an idea or a concept, there is no need to commit the organization totally and utterly. That is quite acceptable because many things could change until we reach the final stage, such as technology that could make designers want to change their initial decision. But as time passes by and we move on to the final stages of process design, the ability to change what designers have planned from the beginning is decreasing, whereas the organization's top management activity is rising.